think the localities. Okay, I think we are good to start now. Okay, count dominant indices. Let's go with the first question of the lead code. And anyone who are new to this YouTube channel, please do comment. Is the audio clear? Yes. Okay. Count dominant indices. And you can also share your thoughts while I'm solving. And if you have any doubts, please stop there itself and ask me the question. Count dominant indices. You are given an integer array nums of length n. This is the first time I am looking at this question. I didn't even solve this question and I didn't participate in the contest actually. So we are given array nums of length n. An element at index I is called dominant if nums of I is greater than average of nums of I plus 1, nums of I plus 2, and so on till nums of n minus 1. Your task is to count the number of indices I that are dominant. So dominant means after that index, all the elements average should be lesser than the nums of I. I think you got it. Now, the average of a set of numbers is the value obtained by adding all the numbers together and dividing the sum by the total number of numbers. We knew that already. The rightmost element of any array is not dominant. Let me tell you. Let's take an example 5, 4, 3 so that we can understand it clearly. Now, we have 5, 4, 3. We are talking about question 1. Now, the last element is not dominant, however, they set us. Now, I am at this index 4. Now, 3. Now, all these elements after that index average should be lesser than nums of I. So, after that element, after the element 4, the only element is 3. And the whole sum is 3 and the number of numbers I have is 1. So it is giving me 3, right? So is nums of I is greater than average of nums of I plus 1, nums of I plus 2, and so on till nums of n minus 1, right? So is it greater? Yes, it is greater. So I'll just round up. Now I have the element 5. Is 5 greater than average of 4 and 3? So the sum is 7 and the total number of elements is 2. So 2 threes are 2 threes 6, right? So 6 sorry, 3 will be the answer for 7 by 2, 3.5, I think so. 3 value is dominant over the subarray. 3.5, yes, here. 3.5 average of 4 and 3 is 3.5. So we need to take it in decimal, nothing but a float value. So 3.5, is it lesser than 5? Yes, so 5 is also dominant. So total number of dominant elements are 2. I think we are good to go to the solution. So what is my algorithm, or do you have any algorithm? Please let me know while I'm telling you. Right. So the algorithm is, or the intuition first. Let's go with the thought process. Intuition is first. If you see, I went from the last and to the beginning. Went from right to left. So first I got a number 3, but it is the last number and there is no element after that number. So what I'll do, I'll just skip it. So skip the last number. Skip the last number. Now I'm going from here, right? So start from n minus 2 and go till 0, right? So I have this 4 right now. I need to have a sum. I need to have the sum of all the elements. First, the sum will be initialized with nums of n minus 1. If you see, nums of n minus 1 will be initialized as our sum. And as we go, we just add that to the sum. Nothing but, nothing but, let me write the intuition here, algorithm here. So for I is equal to n minus 2, I is greater than or equal to 0, I minus minus. And the sum is, however, nums of n minus 1. And I have this for loop. In this for loop, let me tell you, mm, if nums of I is greater than, what is the average? How do we calculate average uh, with the sum? I'll tell you how. So I'll just take a float value, float of nums, sorry, sum by. I am at an index I. So 1, 2, 3. I'm at an index I here, and this is n minus 1. How many elements I have after I? So it will be something like n minus, let me tell you. Imagine n is equal to 4. How many elements I got after 3? Only one, which, sorry, at index I, which is 2. So 4 minus 2 will give me 2 itself. Minus 1 will give me 4 minus 2 is 2, minus 1 will give me 1, only one element, right? So n minus I minus 1 elements after I. So sum by n minus I minus 1. Now this is the, what do you say, the condition. So if this condition satisfies, I'll just increment my count. One thing which we are missing is adding the current element to the sum. What is my intuition here is, this will be, this element will be initial sum, and I'll start iteration from here, from here, and I have this sum, right? So every time, every time check the condition and increment increment the count, right? Every time check the condition and increment the count. Now we are checking the count. iteration from here. Before going, before going to the next element, we before go to this element, we just add nums of I to the sum. That's it. So sum is equal to nums of n minus 1, and we have this count, right, which we need to return. So before going to the next element, nothing but before the for loop, at the end of this for loop, okay, for loop, sum plus is equal to nums of I. That's it. And return count at the last. Let us see whether uh, does this work or not. Okay, and let's see the constants. It would be 100, yes, as I guessed. Okay, this is the question one which we are talking about. So firstly, int count is equal to 0 and int sum is equal to nums of n minus 1 for int I is equal to n minus 2. But we forgot int n is equal to nums dot size. I is equal to n minus 2, I greater than or equal to 0, I minus. If nums of I is greater than, let's take this as float of sum by n minus I minus 1. Just increment the count, and sum plus is equal to nums of I. Then return the count. Let us see whether it works or not. Wrong answer. 4, 1, 2. Output is 2, but expected 1. 2 by 1 is 2. 3 by 2. 3 by 2 would give me double. I think here I need to take it as double. Let us see. 4, 1, 2. Why is it giving me the wrong output? Where is that? Okay. 4, 1, and then 2. So here I don't have to check it. So here at this point, is 1 greater than 2 by 1? 2, 1 is greater than 2, false. We need only 4. Now 4, is it greater than 3 by 2? 1.5. But why is it giving me 2? Let us see. See out nums of I and L. 1 and then 4. Why 1? Mm, Okay, let me take this. So for 1, it is giving me -2. Why is it -2? N minus I minus 1 is giving me -2. Let's check. Okay, okay. N is equal to 3. I is equal to 1. 3 minus I minus 1. 3 minus 1 minus 1. Give me 3 minus 2. Give me 1. Sum. sum by n minus, okay, t is considering n, and then it is considering I minus 1 and okay, what did I, okay, okay, we are good to go now. Let us see whether it is taking, yeah. So n minus I minus 1. So that's the minor mistake, a small mistake actually. So now let's go to the next question. Merge adjacent equal elements. Let us first read the question. You are given an integer array nums. You must repeatedly apply the following merge operations until no more changes can be made. Let us see what are those changes. If any two adjacent elements are equal, choose the leftmost such adjacent pair in the current array and replace them with a single element equal to their sum. Okay. After each merge operation, the array size decreases by 1. Repeat the process on the updated array until no more changes can be made. Return the final array after all possible merge operations. Did anyone understand this question? You must repeatedly apply the following merge operation. Okay. If any two adjacent elements are equal. So while we iterate the array, if any two adjacent elements are equal, something like nums of I and nums of I plus 1 are equal. Okay. So if these both are equal, choose the leftmost such adjacent pair in the current array. Leftmost such adjacent pair. Okay. Leftmost adjacent pair in the current array and replace them with a single element to their sum. Okay. After each merge operation, the array size decreases by 1. Repeat the process on the updated array until no more changes can be made. Return the final array all. And examples are also uh, getting in 4 commas. Is it something like what we let us see? 3112. This is the second question. Question question number 2. 3112. 3112. Now I have these two adjacent elements, right? So if I have adjacent pair which are equal, excuse me, nothing but if nums of I here and nums of I plus 1 both are equal. Now, is there any pair, such pair, which is leftmost in the array? Leftmost in the array, not to 1 comma 1. I'll tell you how. I have 1 comma 1, right? So, which is adjacent pair? Now, what is the leftmost such pair in the array? It is 1 comma 1 itself. So what we will do, we will just make as the set here, such choose the leftmost such adjacent pair in the current array and replace them with a single element equal to their sum. Single element equal to their sum. What is their sum? 2. Now, this is our refined array 3 comma 2 comma 2. Now again we have a pair 2 comma 2 which are equal, right? Now we need to change. We need to look for the leftmost such pair in the array. What is the leftmost such pair in the array? It is 2 comma 2 itself. So it will change to 4 and The elements are 3, comma 4. Now, do you see any equal elements again? No, right? But how can we solve this? I have understood the problem, but how can I solve this? 3, comma 1, comma 1, comma 2. Let's take this 2, comma 2, comma 4. And now, if you see, I have a pair 2, comma 2, which is equal. And what is the leftmost such pair? It is 2, comma 2 itself. I'll just change it to 4, comma, that's the new element. Now the new array will be 4, comma 4. Now, if you see, these two are equal. 4, comma 4 is equal. So, what is the leftmost? Yeah, uh, nothing but 4, comma 4 itself. So, I'll get 8 as our answer. Yes. 375, no changes. If you see, 3, comma 7, comma 5, there will be no changes at all. I think that's it. Um, how can we solve this? That's the actual problem here. And also, we cannot iterate through the array again and again, but there will be some way. There will be some way. Uh, let's take a bigger example first. 1, comma 2, 3, comma 3, 4, and then 5, comma 5, and then here let's take a 6, and then here let's take a 10, and then 1, 1. Let us see what happens. 3, that's it. Okay. Now, I'll just check whether what will be the correct answer for this. 3, comma 3. The leftmost is 3, comma 3, and also I have this 3, comma 3. So I'll just change it to 6, and the next array, new array will be 6, 5, 5, and then 10, 1, 1, and 3, 2, 1. Okay, then 6 and then 6, it is also an array, so 6 and 6 will change it to 12. 1, comma 2, comma 12, comma 5, 5, 10, 1, 1, and then 3. Now 5, 5. We just change it to 10, and the remaining elements are 1, 2, 12, 10, and then 10, 1, 1, and then 3. So it is not, sorry, it is 1, not 12, 1, comma 2, comma 12. Okay. Now 10 and 10. I'll just change it to 20, comma 1, 2, 12, 20, 1, 1, and then 3. 1, 1 will change to 2, to 2. But anyone solve this problem, please let me know in the comment section. Well, I found this something tricky. Okay, 1 to 12, 20, 2, and then 3. That's the last array I can obtain. But uh, but if you see, mm, like, can we take it as a linked list problem? I don't know whether I am making it big or small or easy. What about a linked list? 10 or 5 will be much, I think. But I don't know how we can solve this actually. Okay, merging till there are no operations left. But if anyone is has solved this, please let me know the approach 1, 2, 3, and 3. So why don't we are just merging we are just merging the leftmost adjacent elements, right? So only check from the left. But I have this concern about the indices. How can we handle the indices? That's the problem. Let us see. Okay, now just merging the operations. So let's take a merge adjacent equal elements. So I'm thinking like we need to return the final array after all possible merge operations. So I'm thinking like why can't we only check from left and merge? But the problem here is 1, 2, 2, and then a 4, 4, and then 5, 5, and then 10, something like this. Let's take this array. Now 0, 1, 2, 3, 4, 5, 6. When I am at 2, I'll check. I have a 2 here. Now 2 plus 2 will give me 4. If I have a 4 on the right, I'll just I'll just check whether I have a 8, whether I have a 8. Okay, 2 plus 2 is 4, whether I have a 4. So where do I check 4? Why don't we just build? Okay, let us do one thing. Let us do one thing. My approach is something like my intuition is 1, 2, 2, 4, 5, and then 5, and then 10, right? So at 2, uh, instead of 2, I think we need a DQ here. I think so. So I have a 2 here. We can use stack psi which I create. So how can I actually use a stack? Okay, so you are saying that I have 1. Thanks for this hint. 1 and then a 2. So I'll check whether 2 and 2 are equal. Yes, that's a good one actually. 2 and 2 are equal. I'll just pop 2 from the stack, and 2 plus 2 would be 4. I'll just push 4 into the stack. Then I'm at 4. 4 and 4 are equal. I'll just pop 4 from the stack, and 4 plus 4 is 8. I'll just push 8 into the stack. That's a good approach. Sai, Vijay, Kiran, thanks for commenting. I've been uh, thinking about the solution. 8. So, sorry, 8 and then 5. 8 and 5 are not equal, so I'll just push 5 into the stack. 5 next. The next element is 5. 5 and 5 are equal, so I'll push first. I'll pop 5 and then 5 plus 5 is 10. Or can take array and push one element if equal to back merge and add. That's great, Sai Vijay Kiran. Thanks for attending my live session. Okay, now 10 and 10, just take 10 and 10 are equal, right? So take 10 out and 10 plus 10 will be 20. That's actually a good move and also a thought process. So let us write the algorithm first. Thanks for commenting and I'll try attending this live session. Sai Vijay Kiran, please do subscribe. We need subscribers like you, right? I have been thinking about a DQ kind of stuff. So thanks for this comment actually. Actually, it helped me today to find out the algorithm or the intuition. First thing, we'll use a stack of int, or just as Sai Vijay Kiran said, let us use an array vector of int answer for I is equal to 0 till n if array dot back is equal to, let's start uh, equal to nums of I. So if these both are equal, array dot back is equal to nums of I. Array dot back will be uh, multiplied by 2. That's it. Else uh, array dot pushback nums of I. Okay. And now this will be checked only if array is answer. Sorry, it is not array, it will be answer. Answer. So answer, answer dot back, answer. Now this will be checked only if there will be two conditions. There will be two conditions. Let me tell you what are those conditions. First, answer is not empty. Okay, answer is not empty and answer dot back is equal to nums of I. So we'll just return answer. Amit Vaishnav official. Hard thing in stack question is to identify that stack question. That's really good thing, brother. Really. Stack. Okay, we need to return vector long long. So I need to change it to vector long long. Wait, sorry. Okay, here we'll use vector long long. Actually, when you see this stack cushion, really as Amit bro said, it is really hard to think it's a stack cushion. We can solve this by using a stack, but to convert the stack into an array would again we need to write a loop. So instead we are just taking a vector long long answer and comparing the last element. That's it. Okay. As it can be multiplied with 2 and it might go to a bigger number. That's why they have given us vector long long. Let us now code. Okay. That's the second problem and also not much stuff, but only to figure out it is a stack problem. That's where we are missing vector long long. answer int n is equal to uh, nums dot size for int I is equal to 0, I is less than n I plus plus if answer answer is not empty and answer dot back is equal to nums of I. Okay, then answer dot back into is equal to 2. Else just answer dot push back nums of I. So that's a good problem. Actually, we are just taking a stack, like a stack kind of problem. Instead of using a stack, we are just uh, initializing the answer array itself, the answer array which we need to return 2, comma 4. Okay, 2. Okay, let us do a dry run for these kind of questions. 2, 1, 1, 2. So in the answer, I have first 2. Answer is not empty, but it is empty, so it will go here. And answer dot pushback nums of I, so answer will be here, and I'm at this position 1. No, answer is not empty. Yes, answer is not empty, and answer dot back is equal to nums of I. No, they are, it's false. So else 1 will be pushed back. Then let's go to the next element. It should be while loop. Okay, okay. Sai Vijay Kiran, it should be while loop. So let us see why we actually need a while loop. Okay, okay. I think you are correct. Let me check. One and then one and one are equal. Remove if and put while. Got the wrong answer. Same here. Okay. I think you attended Amit Vaishnav bro. You have attended the contest. Okay. One and one are same, right? Okay. One and same. So I got answer dot back is equal to 2. But what if I okay, mm, let us see by taking a while here, 1 and 1. Okay, 1 and 1. I changed it to 2. And then answer is not empty. Answer dot back is equal to nums of I. No, I need to increment my I. That's it, right? So instead of for loop, first answer dot push back nums of 0 int I is equal to 1 and I plus plus. Okay. Okay, am I correct? Let me know. Answer is not empty. Answer dot bag is equal to nums of I. Let me check. Here, let me come again. So have 1, 1, 2. So answer is 2 first, uh, and I is 1. 1 and 2 are not equal. 1 and 2 are not equal. Okay, let us write if let me guess Sorry. While I press. Okay. Diameter answer dot back is equal to nums of I is less than n. Are we correct? No, we are wrong. Okay, so the code we submitted here is this 2112. 2112. So 1 and 2 are not equal. So 1 will push back. Then 1 and 1 are equal. So I'll change 1 into 2. Then I'll go to 2 here. 2 and 2 are equal. So I'll just change it to 4. Right? So how can I? Okay, we just need a while loop here. Let me check answer. I don't know how. Okay, 2, 1, 1, and then 2. Answer will be initialized with 2 first. Then I got 1 and 2 are not equal. So 1 will be pushed back. Then let's go to 1. 1 and 1 are equal. So I'll just change it to 2. Then I will increment my I pointer here to 2. 2 and 2 are equal. So I'll just change this 2 to 4. Okay. What's so wrong here is expected 4 comma 2. But I got 2 comma 4. I am doing the same wrong when I am uh, doing it right. Okay. Now let us start again. 1 and 2 are not equal. So I'll just push back into this. 1 and 1. 1 and 1 are equal. So I'll just change it to 2. But if you see here, I have 2 and then 2. Okay, okay. Let us not change there. When I have 1, current is equal to 1 into 2. Okay, okay. Let us just remove that. Let me tell you, when I have 1, I'll just remove 1 there and take current is equal to uh, current will be multiplied 1 into 2. Now current and answer dot back are both same. So so let me tell you current will be nums of I if sorry y current is equal to answer dot back. What we will do, answer dot pop back and current into is equal to 2. Let us see whether it runs or not. 2 1 1 2. So answer I have 2. Then I am at here. So my current is equal to 1. While current is equal to answer dot back, no, no. Then answer dot push back, excuse me, answer dot push back current. Let me tell you. So I have answer is equal to only 2 and I am at 1. 1 is my current. Current is equal to answer dot back? No. So answer dot pushback current. Answer dot pushback current. Now I am here and my current is still 1 here. This element is my current. Current is equal to answer dot back? Yes. Answer dot pop back? Yes. Current into is equal to 2. Okay. Current will be multiplied with 2. Current is equal to answer dot back. If you see 2 and current both are equal, what I'll do? Answer dot pop back. Yes. Current into is equal to 2. Current into is equal to 2. 2 will become 4 now. Now, current is equal to answer dot back, but answer is empty, so I'll also check. Answer should not be empty and current is. Then answer dot pushback current. Now the answer will be 4. Then I'll go to the next element 2. Now 2, while answer is not empty. Yes, answer is not empty. Current is equal to answer dot back. Current is 2. Sorry, current is 2 now. And current is 2. 2 and 4 equal no. Answer dot pushback current. Okay. So for I is equal to 0, I is less than n. Let me see. We can also say it as and current into is equal to 2. Answer dot pop back. Now long current is equal to nums of I. So dot push back. Let us see. Let me run this. Else there is no need of else. Answer dot push back instead of nums of I'll change the current. That's a good problem here. No. Still I got 8. Okay. So the push back of 0 I is equal to 1. No, still I got a wrong answer. Let me check again. 2 comma 1 comma 2. So answer is 2 and I have here. So my current is 1. Answer is not empty and answer dot back is equal to, sorry, here I need to check with current. Instead I checked with nums of I. So I think you are clear, and if you have any doubts, please let me know. We have, I think, solved the second problem. Let me check, do I get any wrong answer? Yeah. Okay, we have successfully solved the second problem too. That's a good problem actually. The stack problems are really hard to guess it is a stack problem, right? So current is equal to answer dot back. Here I wrote it correctly, but when it comes to code, I didn't change it. Answer dot pop back and current is equal into is equal to 2. So dot push back current. I think we are good to go. I think we can also do it for I is equal to 0. Okay. It doesn't change. When it is I is equal to 0, we are just push we just push back at this point. Okay, so if you see, many of the people have solved this problem. I think there are many other methods to solve this, and even we can solve it with a stack, but uh, having solving it with stack would be somewhat we need to just take all those elements again in a reverse order, right? So that would be a can let us see. Let us see how many subscribers do we got. There will be weekly live sessions. And also this week I'm also planning for a Valentine's week where we deep dive through the data structures and algorithms. It will start at 8, not 8 p.m., at 9 p.m. today, and it will continue till Saturday. Yes, I can say that it will be continuing till Saturday. Yeah. So we got 922 subscribers. Let us see with the analytics. Can we go? Let us go to the next problem. Or we'll be going to the next problem. But can we reach 1000 subscribers? I don't know whether, let me tell you one thing. When I when I dream about or make a goal, I don't consider anything like where I am, where I come from, and what is my current anything. I don't set any goal with making all these factors in mind, right? So that's what which goes me to the next level every time. So can we go and get 1000 subscribers before we end this live session? It's just how many? 78 subscribers more? No. Count subarrays with cost less than or equal to k. You are given an integer for any subarray, define its cost as max of nums of L to R minus minimum of nums L to R into with cost less than or equal to k. Okay. Okay. The integer denoting the number of subarrays of nums when cost is less than or equal to k. No. Mm, let us see. R minus L minus 1 is nothing but the size. He's not mentioning the size. I don't know why. R minus L minus 1 is itself size. Uh, Let us do a dry run. Oh, sorry, a brute force, and then check whether how can we solve this. Question 3. Count subarrays with cost less than or equal to k. Count subarrays with cost less than or equal to k. Okay. No. So cost here they said cost is equal to max of subarray minus minimum of subarray into size. That's the cost. And return, it's just articulated clearly. Return the number of subarrays with cost with cost less than or equal to k. So we are given with k and also the array itself, right? So let's do a brute force first. I know it won't be working for the constant. Let us see the constants is 10 power 5. I know it doesn't work. Let's use this pink color. Okay, I don't know what day it is in Valentine's Week, but 1, 3, 2, and k is equal to 4. But let's do a brute force. First, how can I use a brute force? I need a maximum element and also the minimum element. Max C, I'll initialize it with int minimum, and mini, I'll initialize it with int max. But if you see, I need for I is equal to 0, I is less than n, I plus plus. For j is equal to I, j is less than n, j plus plus. I will have this maxi and mini, maximum number and minimum number here, and I'll just change every time. Maxi is equal to maximum of maxi comma nums of j, with the same thing. Mini is equal to minimum of mini comma nums of j. Is there anything? No. The cost is equal to, what is the cost? Mm, I is equal to 0, j is equal to I. Okay. The cost will be maxi minus mini into the size will be j minus I plus 1. I think you got it, but if you don't get it, please let me know. Cost is less than or equal to k. Count will be incremented. We'll initialize n is equal to nums dot size, and then count is equal to 0. I think long. Yes, that's it. Return count. Okay. Yes, okay. Here int n is equal to nums dot size, and long count is equal to 0 for int I is less than n I plus plus. Now maxi and mini, long. Do we have to take long? Yeah, I think so. Long max is equal to L long min, mini is equal to L long max. For int j is equal to I, j is less than n, j plus plus. Max is equal to max of maxi gamma nums of I into 1 long. This we just take. Now cost is also long. Maxi minus mini into j minus I plus 1, and if cost is less than or equal to k, count will be incremented, then return the count. It's just a brute force which might not work. Let's also get the wrong ones. In time error, long cost is equal to mini minus. This is the problem with, okay, no. Long cost is equal to maxi minus mini 1 long into what error we are doing here, j minus I plus 1. Wait a second. So, okay. So if maxi is not is equal to a long min and mini is not equal to a long max, then only I'll just compare it. Okay. We got a wrong answer. The output is 0, but expected is 5. Let us check. J is equal to I, J is less than N. Okay. Why didn't change? For one, uh, okay, nums of I. Let us take nums of I. Then we don't need this, need this. Yes. 1, 1, 1. What it is? So if you see, I'm just comparing again with the nums of I instead of nums of j. So the minor mistake or the small mistakes, okay. Then I got a nums of j. Take maxi and min 1 1 square I, j is less than n. But why did I get 3 again as? Okay, I got 3 as maxi. Sorry. So that's the problem with uh, just taking the upper line to the down. So time limit exceeded as expected. But how can we go and make it short? Is it a stack problem? I think so, no. A priority queue, subarray, right? C minus me. Okay, I got no idea here. That's the third problem. What will be the topics weekly contest? Okay, don't use sliding window. Decay is useful for maintaining the maximum go of time per operation. The current window's cost exceeds k. Remove the left boundary for until the window becomes valid again. Count all subarrays ending at the current right boundary. Okay. window becomes valid again for the left boundary. Let's just use L and R. Int L is equal to 0, R is equal to 0, while R is less than M. So a DQ mm, a DQ, right? How can we use a DQ? Okay, okay. I'm just naming it as DQ, while R is less than M. No, while cost, while so when the current windows cost exceeds K, move the left boundary L plus plus. But here also the DQ needs to be uh, can we use a multiset instead of multiset multiset in C++? Let us see multiset. And as we are gonna restore elements on and allows duplicate values. Okay. Erase remove all occurrences. No, not all. Remove only a specific instance. And, okay. Erase only one element. Let us see. There's only one instance. We should use erase function with an iterator point for the element you want to remove. If okay, we need to find the element every time. What if we use hash map? I think so. It would work. Hmm, how to use a hash map to store in a sorted order and that's it. Sorted because it's a tree map. Can DQ be sorted? Yes, a DQ can be sorted, but this will yes. Okay, how to remove an element from a DQ? This is in C++. So removing elements from the else component or not. If the first element removes the last element, but it doesn't remove. Okay, DQ, how can we win the currency? Will be the discussion. Oh, I'll get copy pasted in ranking. You can't. This one should be hard. They are just using all the tools. I don't know how they get rank 1 and rank 10 would be something like in just a few minutes. In just a few minutes, they are just solving all the four problems in just seconds. Right? This one should be hard. So, not the question. Window maximum open link in window sliding window maximum would be. I think I have solved it. Yeah. DQ is not empty and DQ dot front is equal to I minus K. While DQ dot empty is not empty and nums DQ dot back is less than or equal to nums of dot quality set, yes. Yes, we can use a multiset. That's what I thought. Set of in M S is in MS dot insert nums of R. Now, while cost is greater than K, what we will do at L, ms dot erase. How to erase only one element from a multiset. So this is the find method. Set to erase one. Int uh, value is equal to nums of L, right? Auto it is equal to auto it is equal to ms dot find value, and if it is not equal to ms dot end, ms dot it is only the single limit ms dot is it, that's it, L plus plus. The cost will be changed again. Cost is equal to ms dot back minus ms dot begin, and begin R minus L plus 1. I think we are good to go. Count, count plus is equal to 1. Okay. Insert. It's a spelling mistake. Okay. Cost long long 1 LL into we got a wrong answer. So count n minus r plus 1. I think so. All the elements which are all the subarrays. No. Next dot r begin, reverse begin. The last element minus the first element will be the cost every time. But how can I increment the count? So okay. I don't know how do I increment the count? Next dot insert nums of I. Think count summarize. This is a sliding problem. Right. Yeah. Okay. Okay. Now what I did here was answer. No, it wasn't like it was something like a DQ type. Let us see. No segmentary flow. R minus L minus R minus L plus 1. The whole size actually. Yes. Yes. So let us do it. So instead of adding only one or adding all those to the last, we'll just add R minus L minus R minus L plus 1, the whole subarray, right? Long image not all the need type int. 1 LL into 1 LL. I think it would work. Here, take this test case. Yes, let me run it. So it is going integer overflow. Now again, okay. I think we will be somewhere at some time. We'll be solving the fourth problem. Maximum score using I don't know much about the dynamic programming at all. Still, the 3D DP, it might take me at least a month to excel in this. So till then, we'll meet again. We'll meet again. The algorithm which I didn't even took, right? So the algorithm will be something like R is equal to 0, L is equal to 0. It is just a sliding window. R is less than N and R plus plus. Now, we'll be using multiset insert nums of R, right? Cost is equal to ms dot just the maximum minus ms dot R begin will be the maximum element minus ms dot begin into R minus L plus 1, right? So that's the cost. Now, while while if you have the cost is greater than k, we'll just remove nums of L and L plus plus and also take the cost after the L plus plus. We'll calculate the same cost here and sorry, I went to the previous question. So after this cost, we'll just increment the count by R minus L plus 1. And R will be incremented, we'll just return the count at the end. The count is equal to 0. So that's how you solve this problem. And if you have any doubts, please let me know in the comment section. And thanks for watching this live session. And if you have any doubts, please let me know. We'll be ending this in 7 minutes exactly at 12 p.m. Right?